we use a problem that is a decimal times a decimal. So here we have 3.3 times 2.6. Now don't forget, this is actually 3 and 3/10 times 2 6/10. So we need to create 3 rows plus 3/10 of a row, and each of those rows needs to contain 2 whole squares plus 6/10 of a square. And I've shown the measurements of this with those red lines and then boxed them out so that I can see those occurring within the array. So if you do cast your eye inside the array and look at the dark lines to see where the whole squares are, we can see clearly across each row there is 2 whole squares and then 6/10 of a square on the right. And then as we cast our eye down through the array, we can see there is 1 full row, a second full row, a third full row, making our 3 rows, and then only 3/10 of a row, making our 0.3 of a row. Now, of course, I want to quickly break this into whole numbers and solve that easier times table first. So instead of looking at rows that are 2.6, I'm interested in looking at rows that are only 2 long because they are whole numbers, and then I'll worry about the 0.6 separately. Similar, casting my eye down, 3.3 rows doesn't sound too easy to me, but 3 rows to solve sounds a lot easier to solve. So I'll break my array that way as well. And then I have a very easy array there to solve, 3 groups of 2. So I'm going to be able to solve that one very quickly. Then I've got 3 rows of 0.6. 0.3, or 3/10 of a row of 2, or I can reverse that in my mind and think of it as 2 groups of 0.3, which we will explore in a moment. And then I've got the trickiest, smallest part of the array, which is 0.3 times 0.6, which we need to unpack and make sure we're understanding what that actually means when we get to it. So 2 groups of 3 is 6, and that's pretty self-explanatory, one of our easiest times tables. Then looking at the next section of the array, we have 3 groups of 0.6, and in light blue I have just boxed out each group of 0.6 so you can see it. So you can see there is the top row is 1 group of 0.6, then the next group of 0.6 is the middle one with the arrow in it, and then the third group of 0.6. So 3 of those would give us 1.8 when we add them together. Moving on to the next section of the array, down the bottom here, we have 0.3 times 2. Now, I've actually reversed this times table and thought of it as 2 groups of 0.3 and boxed them out in purple. So you can see that I've got 1 group of 0.3 with the arrow in it on the left, and then next to it, this second group of 0.3. So 0.3 plus 0.3 will give us 0.6, or 6/10. Now moving to the trickiest section, which is the smallest section. We have 3/10, or 0.3 groups of 6/10, or 0.6. So let's think about that for a moment. We have 3/10 of a group. So we don't even have a full group of 0.6. We only have 3/10 of a group of it. So we know straight away our answer will be smaller than 0.6. And again, thinking of what 0.6 is makes it easier. 0.6 means 6/10. So we have 3/10 of 6/10. So let's have a look at what 0.6 is to remind us. So this here is 1 group of 0.6. And you can see our little array in the corner here is much smaller than that. So we've only got 3/10 of that. So when we do our multiplication, it is actually going to give us 0.18, much smaller. If we look inside the array and actually count how many little squares we've got in there, you'll see that there's 18 little squares. And that's because each tiny square in this grid page when we're calling each large square 1 is a hundredth. So there's 18 hundredths in that little box. So some people like to use multiplication tricks. So they'll do 3 times 6 is 18, and then they'll move decimal points around. But I find it much more valuable just to be aware of what's actually going on. So if it's 3/10 of 6/10, then that means 1/10 of 6/10 would be 6 hundredths. So 3 of those would be 18 hundredths. And that's how we get 0.18. So it leads to a lot of confusion when we're starting to multiply decimals by decimals. So we really need to be on our game. And I'd encourage you to really stick with whole numbers multiplied by decimals, as we showed in the previous examples, and being very confident with those before moving on, as it does get quite complicated. Now we've got our 4 totals from those 4 different arrays that we've cut from our large array, and we can add them up. So it's 6 plus 1.8 plus 0.6 plus 0.18, which will give us 8.58. And that's what 3.3 times 2.6 equals.